Ridwan. My name is Iqbal from Tenaga Nasional Berhad, Malaysia. First and foremost, I would like to thank Smart Grid Forum for giving me another opportunity to present in IEC 6150 Global 2020 Conference. I had the honor to present in the 2018 version of the conference, where I shared about our experience in conducting Edition 2 testing. So today I would like to share our experience in conducting top-down SCL engineering process for a fellow Southeast Asian country or Asian utility company. These are my presentation contents. First, I would like to share our experience in implementing IEC 6150, and I will touch a little bit on the overview of IEC 6150 SCL and the engineering process, especially the ones updated in Part 6, Edition 2.1. And then I will share the case study that we have conducted with our fellow Asian electric utility company. For those who don't know, Tenaga Nasional Berhad is one of the major utility companies in Malaysia. We operate at the Peninsula Malaysia, the west side of Malaysia. On the east side, we have two big utility companies, Sarawak Energy and Sabah Electricity. Sabah Electricity is a subsidiary of Tenaga Nasional Berhad, whereas Sarawak Energy is operated by the state government. Now, a little bit about Tenaga Nasional Berhad or TNB. It is still a vertically integrated utility company, though the generation market has been liberalized. So we have generation, transmission, and distribution and retail divisions. Now, a little bit about myself. Previously, I served as a principal researcher in TNB Research Sdn Berhad, also a wholly owned subsidiary of TNB. I led IEC 6150 related research, design, engineering, testing, and training works. I just joined this new subsidiary, TNBX Sdn Berhad, which is a subsidiary of TNB Retail Division last year, where my main responsibilities are business development and project management for behind-the-meter solution. However, I am still being called by my former workplace, the research department, and also other entities, local and international companies, to provide advice on IEC 6150 related works. Now, on our IEC 6150 journey, it all started in 2007, where we initiated a feasibility study to develop a laboratory as a fundamental facility to test and develop internal competency regarding IEC 6150. The lab was completed in 2010, and furthermore, in 2012, we have initiated the product acceptance process and started research works on process bus. In parallel, the transmission division of TNB started a multi-vendor station bus substation project. In 2015, we have successfully completed a field trial installation of optical current transformer for one bay. And we have commissioned the earlier mentioned multi-vendor substation project, and we also started the migration projects for legacy substation control systems to IEC 6150. Since 2018, we have initiated the Edition 2 product acceptance process, as the number of IEDs that comply to Edition 2 has increased. Therefore, we had to devise and formulate the test procedures and test outcomes based on IEC 6150 Part 10 Edition 2 as well as UCA IOP final reports. And we have also initiated a enhanced R&D project on digital substation. This is a continuation of the project we had in regarding process bus in the past. And from our experience, we also discovered that education, internal competency development has been a crucial issue with regards to full-scale deployment of IEC 6150. Though we already had an official training syllabus for IEC 6150 in our training center, but it was deemed not enough, as many of the attendees took the subject matter as a touch and go or one-off knowledge sharing session. Therefore, the TNB Grid Division has decided to incorporate IEC 6150 as a part of learning journey for protection and control engineers. And last but not least, we have also initiated, or should I say enhanced, the project implementation process for IEC 6150 projects. This includes not only standardization of specifications, but also drawings, terminal diagrams, and also education on testing companies for commissioning. So these are the list of the R&D projects that we have conducted from 2007 to 2019, where the last project here is an ongoing project. Though the progress is a little bit hampered because of the pandemic, we have successfully commissioned a, or should I say, upgraded version of the laboratory that we completed in 2010 with the state-of-the-art IEDs comply to IEC 6150 edition 2.1. Now, as far as the architecture of migration-related projects, it was decided that the communication foundation and the focus should only be on station bus. This is specific for migration projects, nothing to do with the full digital substation projects or R&D projects that I have mentioned earlier. So this will be the guideline for migration projects where hardwire connections are still present for tripping functions. Goose application, however, will be fully implemented for interlock and auto reclose, also for digital fault recording initiation functions. Now at the station level, we've included devices such as engineering gateway or enterprise gateway to be connected to a system for condition and online monitoring purpose. And also we have this is a TNB term for station HMI, and also your normal SCADA gateway. Now, I would like to highlight on the overview of IEC 6150 System Configuration Description Language, SCL, and the engineering process. So we all know that to achieve a top-down engineering process, it starts with the system specification or single line diagram, which is translated by the system configurator tool into SSD file by including ICD file, template files from the IEDs. We are able to integrate and configure them to produce an SCD file. This SCD file will be sent to IED configurator, and then this IED configurator will create an optional CID file or in certain implementation X factor file for edition 1 devices to be imported or uploaded to IEDs. In edition 2, we were introduced to the IID file where it can be used to modify configurations from the earlier developed SCD files, or it can be used to pre-configure IEDs to instantiate certain elements. So from experience, the latter is more prominent, where IID files are most used to instantiate elements as part of pre-configuration before we import the file into the System Configurator tool or SCT tool. Now, in the revised version of Part 6, or commonly known as Part 6 Edition 2.1, The standard already acknowledged the mixture of additions in engineering process, where it was highlighted that an addition 1 IED can only work with a tool that supports both addition 1 and addition 2, whereas a tool that supports both addition 1 and addition 2 can always work with addition 2 devices, meaning that there's no direct engineering that can support addition 1 into addition 2 configurations as far as SCL is concerned. In the same standard, Part 6 Edition 2.1 highlighted 6 methodologies in configuring mixed editions of SCL files. So number 1, using a single system configuration tool, SCT tools, where perhaps this is a more common one if we want to configure a mixture between edition 1 and edition 2 devices, where it will require a downgrading from the SCT tool. Number 2 is slightly less common if you were to use a third-party SCT tool, where normally a utility company will not have more than one third-party system configuration tool, because of the price. But 6150 Part 6 Edition 2.1 does highlight the process where SED file is used for exchange between these two tools. And there's also a process highlighting the hybrid Edition 1 and Edition 2 engineering process. However, this is only for the IED tools that support both Edition 1 and Edition 2 in the IED tools themselves. So number 4, things are getting more complicated. I personally have not seen such implementation yet, where Edition 2.1 and Edition 2 are mixed and used, and multiple SCTs are used. I've never seen such implementation, but the standard highlighted this process as well. Number 5, similar, Edition 2.1 and Edition 2, but using single Edition 2.1 SCT. So from this diagram, you know that for this to work, the SCT itself must support Edition 2.1. And last but not least is the downgrade from Edition 2.1 to Edition 2. Pretty much similar to the first methodology, where the system tool play a role to upgrade or downgrade the output SCD file. But in this case, it is from Edition 2.1 to Edition 2. Now, on to the case study or project that we had with our fellow Asian electric utility company. A quick background on this. I myself was appointed as consultant by this company in September 2019. The project objective was to prove a working IEC 6150 top-down engineering process in a multi-vendor laboratory environment. Unfortunately, I'm not at the liberty of sharing the details of this utility company, as we have signed NDA with them. However, to a certain extent, I'm able to share the results, in which obviously I have to mask the final results, which I will present shortly in this conference. And for the record, this utility company is one of the pioneers of IEC 6150 in ASEAN country, where they started way earlier than TNB in 2005. But their implementation more than 80% of their substations are still using single vendor implementation. Hence, after, if I'm not mistaken, after they have completed their 30th substation using single vendor IEC 6150, this utility has decided to have a dedicated team to pursue on multi-vendor engineering process. Hence, I was called in by this utility company to assist them in proving that top-down engineering process do work. And they were skeptical at first, as they did not believe anyone who told them that such top-down engineering process, especially for multi-vendor environment, is possible. So these are the list of IED involved. We have mostly addition 2 IEDs and a single unit from Toshiba, which was on addition 1. And the success criterions for these projects, including the successful import of SCD file from SCT by the ICT or IED configuration tool, and not stopping at the engineering. So we also included the success criterion as the successful initiation of signals, where after we import, we simulate certain signals to ensure that the engineering process do work for the project. And these are the tools used. For the SCT tool, we've utilized SCL metrics from Grid Software. For client simulator, we use IED Scout from Omicron. And of course, not forgetting the ICT tools from respective IED vendors. So just a snapshot of the engineering flow. So this is the final result when we have completed the engineering process. This is in SCL matrix, the SCT tool. This is called the data flow diagram, where you can see the IEDs connected to a subnet and conduct information exchange between them. So we do configure GOOS publication and subscription, as well as client-server communication from a certain report control block to the station HMI. And this was the interesting part. For subscription input configuration, we had to choose either predefined GOOS for input in IEDs or utilize this no logical node feature for input binding in ICT. This is because some of the IEDs already specify specific logical node for GOOS input, whereas some IEDs do not allow us to configure input in just any logical nodes. So this limitation, not to say limitation, it is a challenge in edition 2, which I believe has been made clear in edition 2.1 with the introduction of external reference attributes. Now, although we tried to follow the first methodology, which I highlighted earlier, unfortunately, for the edition 1 IED in the project, we had to devise our own method to downgrade the SCL files to ensure the import in edition 1 ICT is successful. So our process is a non-standard process, where first we export the CID file from the SCD file created in the SCT tool. Then we use IED Scout to import the exported CID file. Then using a feature in IED Scout, we save the CID file, originally edition 2, as edition 1 CID file, where Omicron IED Scout provide option to save as different SCL schema versions. But this did not provide any much difference in terms of engineering. And last, the downgraded edition 1 CID file is imported to the Edition 1 ICT. Then, to a certain extent, we are able to engineer Edition 2 SCD file into a Edition 1 ICT. And, ladies and gentlemen, so this is the tool interoperability matrix that we have achieved in this project. So as you can see, the subscriber part mostly are Edition 2 IEDs with only Edition 1 IED. As you can see, I've masked the vendor names here. But by having this matrix, we know that these are the methodologies and input method that need to be considered when conducting a top-down engineering. Therefore, should this utility company wants to conduct a separate engineering process for a different site using the same IED vendors, they may refer to this matrix for their engineering process. And of course, if they want to include new IEDs from different vendors, they can just extend this matrix as reference. So, another important highlight in this matrix that you can see, some of the IEDs here specify inputs using specific logical nodes, whereas certain IEDs does not allow the SCT to define the input. The input had to be defined when the SCD file, after the SCD file is imported in the ICT2. And I would like to have your attention to the rightmost matrix. Unfortunately, the non-standard Edition 2 to Edition 1 downgrade process only work with 2 Edition 2 IEDs only. We did not able to configure for the remaining 2 IEDs. Okay. So as a conclusion, generally, the project has proven successful information exchange can be achieved from top-down engineering approach. And again, generally, we did not encounter any major issues when importing SCD file generated from third-party SCTs. This is with the exception of if we mistakenly configure the communication part, which certain Edition 2 ICTs will not be able to read the SCD file. And as I have mentioned, for Edition 2 to Edition 1 IED engineering, non-standard downgrade process was the only way for successful SCL file import in Edition 1 ICT. But as you can see, we only able to configure 2 out of 4 Edition 2 IEDs. And we had to utilize the no logical node method in the SCT because certain ICT did not allow insertion of new external input in SCTs. And some of the issues mentioned earlier was also observed in the UCA IOP 2019 final report, where mostly related to implementation issues in ICT and IED vendors. Last but not least, the latest version of SCT that we use for the project now fully support external reference attributes as outlined in IEC 6150 Part 6 Edition 2.1. This is to be tested in the ongoing IEC 6150 Digital Substation Project and the laboratory in TNB Research. I personally have not yet tested this attribute, but I look forward for the actual works, hopefully after the lockdown have ended by the end of this month. With that, I thank you for your attention and I welcome any questions or comments to my presentation. Thank you.
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organisations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.